So now we will start talking about how to combat the web spam. And the method we will talk about is called TrustRank. So as we mentioned before, there are two types of web spam. There is the term spam and there is the link spam. Term spam, you can think of it as it's very similar to the email spam filtering, right? Basically, we would like to identify what are the terms, what are the words that correspond to spam, and for every web page, we would like to automatically say whether it contains a set of those words and filter out the web page. Combating link spam, however, is more expensive or more tricky. The idea here is basically that we would want to detect or blacklist a set of graph structures on the web that look like spam farms. In particular, what is the problem here is that kind of this leads to another war where if we would have such a filter that would try to identify structures that look like spam farms, is that then spammers would try to hide themselves and we would have to update that blacklist and everything would go back and forth. So we need a more universal solution. So the more universal solution is called TrustRank. And in its basic idea, TrustRank is simply a topic-specific PageRank with a teleport set to a trusted set of web pages. Right? So when I say, for example, trusted set of web pages, this would be web pages to which we trust and that are not likely to be hacked or farmed. So, for example, .edu domains or from non-US schools would be such a way to identify a good set of trust web pages. So let's think about this a bit more and see what is the idea. So basically the idea behind the TrustRank is the notion of approximate isolation, where the idea is that it's rare for a good page to point to a bad page, right? It's very rare that a good legitimate page would point to spam. So the idea is that we want to select a set of seed pages from the web that we trust, that they are good, and then we would want to compute some kind of similarity or importance or proximity of all the other web pages on the web to this trusted set. And now, if some other web page is legitimate, then it will be close to the trusted set of web pages. Of course, what we are depending on here is that we have some oracle, right, some human, to identify good, trustworthy set of web pages. And of course, that the idea is that web spam pages are not in this set. Of course, this is a very expensive task because a user would have to go, or a human would have to go through and do these labels. So in some sense, we want to make this set of seed trusted web pages as small as possible. So the idea is the following. What we basically will be doing is we are doing the trust propagation. So basically we have a subset of good seed pages that we identify as good as we will call them trusted pages. And then we perform, as I mentioned before, the topic sensitive PageRank with the teleport set to the trusted pages. What this really means is that now basically we are propagating trust across the links of the graph. Right? And the trust can take value between 0 and 1, the same way as the PageRank score. So one possible way to identify spam would be the following. We take the set of trusted web pages, we compute the personalized or topic-specific PageRank score with the teleport set being the set of trusted web pages. And now what we do is we compute the PageRank score of every other page on the graph. And if the PageRank score of some page on the web graph is smaller than some given threshold, then we go and cut that page away from our data set, and we say that that corresponds to spam. The problem with this method, though, is that basically we go and cut away all the web pages that have low PageRank scores with respect to the trusted set. And now, of course, some web page on the web can have a low PageRank score because this web page is new and has just been born, or this web page can have a low PageRank score because it's spam. So the question is, why is this a good idea, and maybe can we later improve on this idea? So let's first talk about why is this idea of personalized PageRank score from a given trusted set of web pages a good idea to detect link spam. So first this notion is that we have this notion of trust attenuation, where the degree of trust conferred by a trusted page decreases with the distance from that page in the graph, right? So kind of farther away a given page is from the trusted set of pages, the lower the trust it receives will be. And another important notion that also works in our favor is the notion of trust splitting, right? Where the larger the number of outlinks from a page, the less scrutiny a page author gives to each outlink. In a sense, what what this means is that if a page has lots of trust but then has lots of outlinks, then this trust kind of gets split into these small chunks and distributed over the target pages, right? And this is exactly what is happening in the topic-specific PageRank with the trusted set of web pages being the teleport set. So now let's quickly discuss how do we go in practice to pick a seed set. Picking a seed set, we have kind of two conflicting considerations. In some sense, we would want to make the seed set to be as small as possible. Why as small as possible? Because human labeling web pages as trusted or not is very expensive, so we want to use as little of human time as possible. On the other hand, we would like, in some sense, to be the seed set to be as big as possible because we want to cover all the good pages on the web. So in a sense, ideally, we would like to put every non-spam page into our seed set. But that would mean the seed set is huge. So the question is, how do we balance out these two kind of competing or conflicting goals? The idea is the following, right? For example, imagine that we want to select a seed set of K pages. One idea would be, for example, that we pick the K pages on the web according to the PageRank, and the hope is that the top small fraction of web pages on the web are really the truly important pages on the web, and we label those as the seed set. Another idea that I briefly mentioned before is that we use a set of trusted domains whose membership is controlled by some trusted organization. So for example, .edu, .mil or .gov domains, these are the domains that not just everyone can register. So all the pages in these domains, we would trust them to be good pages and that are not spammy and don't point to other spammy pages. So one way to create a trusted set of web pages would simply be to take all the web pages at these domains. What is also interesting now is that we can actually take our initial idea of identifying web spam and extend it a bit. And we will extend it by creating this notion of spam mess, right? So the idea is the following. We will use the TrustRank as a model and start with a set of good trusted pages and propagate the trust. But now we will flip our reasoning and we will kind of use two complementary views. Our goal will kind of be to ask what fraction of PageRank comes from the spam pages, right? So what we would like to do is not to ask what is your proximity to the trusted part of the web, but we would like to say what fraction or estimate, what fraction of PageRank score of a given page comes from the spam. Right? So in practice, we don't know the answer to this question, but we need to estimate it. So the way we can think about this is the following. We can think that we have our web page that we are interested in here as a red circle. We have a trusted set of web pages, and we have the full web. And our goal is to estimate what fraction of PageRank score of our red node here comes from the spam pages. So what we can do is proceed as follows. We can first go and compute R sub p, where p is our red node, where R sub p is simply the PageRank of our node p. And then we can also compute the R plus of p, which is the PageRank of the same node, where the teleport was done to the trusted set of web pages, right? And now we can say that the spam mass of a given web page is simply Rp minus R plus p. What does this mean? Basically, is we say we will compute the PageRank score of a page using the simple PageRank where the teleportation is uniform. We will also compute the PageRank score of a page where we always travel from this trusted set of web pages. And now if a web page is really spam, then this difference will be high, right? Basically, there is a lot of other web pages on the web that we don't trust that really boost the importance of that page. So this way, we can define the notion of a spam mass of a page, which is simply the ratio of the overall PageRank score of the page and the amount of spam mass that page receives. And this way, we could go and all the pages that have this spam mass fraction high, we would proclaim these pages as spam and remove them from our web corpus. And this idea is better than the first solution to our problem because here the question whether a page is spam or not does not depend on the absolute value of its PageRank score, but kind of it depends on the relative value when we compare how much PageRank score of a page comes from the trusted part of the web and how much of its PageRank comes from the untrusted part of the web. And the ratio between these two quantities tell us how spammy is a web page.